When a water treatment facility treats chemical pump replacement as a monthly routine, the equipment itself is rarely the root cause. Consider a 3.2 million gallon per day municipal facility. They were dosing 12.5% sodium hypochlorite at 28 gallons per day. This setup triggered a complete pump failure every 4 to 6 weeks. Annually, this cost the facility over $18,000 in parts, labor, and unplanned downtime. These repeated failures occur because the facility is specifying materials that cannot withstand the exact chemical concentration and operating temperature of the site. The physical evidence is clear. On the left is an elastomer O-ring pulled from a failed bleach pump, visibly swollen and distorted. On the right is a pristine O-ring maintaining its rated cross-sectional geometry. A chemical service rating on a pump is meaningless unless verified against the specific concentration and continuous duty cycle of the installation. Achieving multi-year uptime requires reverse engineering the material failures before the next purchase order is signed. Engineers often specify EPDM seals because the material performs well in ozone, steam, and dilute water-based fluids. Standard compatibility charts often give EPDM an acceptable rating based on 70-degree test conditions. But once the concentration shifts above 10% available chlorine, that rating is no longer valid. In continuous high-concentration service, the oxidizer breaches the material at the molecular level. The EPDM polymer chains absorb the oxidizing chemistry directly into their matrix. As the chains break down, the elastomer expands. The O-ring swells until it pushes out of its seating groove and allows fluid to bypass the seal. In a metering pump, the O-ring must maintain precise geometry to control the sealing surfaces. Once the elastomer swells out of tolerance, the pump loses volumetric control. This degradation is an electrochemical certainty. Every EPDM failure in this environment is a result of the schedule, not a defect. FKM, commercially known as Viton, is the precise fluoroelastomer fix for this application. FKM uses a fluorine-carbon backbone that natively repels oxidizer absorption. This allows the seal to maintain its exact dimensions and integrity in sodium hypochlorite concentrations up to 15%. While FKM stops the seal failure, a chemically resistant O-ring is ineffective if the surrounding pump architecture is susceptible to the same oxidizing attack. Securing the elastomer is only the first step. The entire fluid contact pathway must be evaluated. Placing premium FKM seals inside a standard PVC valve body still leads to long-term failure in high-concentration service. Under continuous exposure to high oxidation and UV light, standard PVC becomes extremely brittle. It slowly microcracks and fails. PVDF is the engineering standard for the pump's main fluid section in aggressive service. PVDF maintains its tensile strength and will not soften or swell in 15% sodium hypochlorite. This exploded view shows the highest wear components in the wetted path, the check valve balls and seats. These components must be specified as PTFE to ensure chemical inertness and zero-dimensional shift during high-cycle operation. Achieving a reliable chemical feed system requires a zero-compromise approach to the wetted path. A single reactive component will eventually cause the system to fail. Even with perfect materials, chemical off-gassing can destroy pump performance. Sodium hypochlorite slowly decomposes in the lines, generating microscopic gas bubbles. These bubbles travel out of the storage tank and accumulate within the suction line. This causes gas lock. The vapor trapped in the pump head simply compress and expand with the diaphragm, and the pump moves zero actual liquid. To prevent this, suction piping must be kept short, ideally under 5 feet. The pump should be installed below the liquid level of the supply tank to maintain positive pressure. Avoid upside-down U-shaped bends in the piping. These act as permanent vapor traps. The physical routing of the pipes is just as vital to system uptime as the polymer of the seals. The Graco Mongoose electric diaphragm pump is a hardware platform that meets these strict wetted path rules. In its plastic fluid section configuration, it utilizes a PVPF housing, a PTFE diaphragm, and FKM check valve seals. This combination of materials is specifically designed for low-flow dosing in water treatment environments. However, matching the materials is only half of the specification. You must also match the hydraulic. Graco Mongoose model would be a sizing error, regardless of its materials. Because a pump's output changes with system back pressure and stroke length, the design must include an operational margin. To hit a 28-gallon per day dose reliably, the facility should scale up to the 30 or 45 GPD models to provide a necessary safety margin. True system reliability occurs when a chemically entered fluid path is paired with rigorous flow and pressure safety margins. Field installations often deal with unpredictable back pressure. In systems with under 50 psi of back pressure, the lack of resistance can cause the pump to overpump. Installing an inline check valve on the outlet line provides the mechanical resistance needed to maintain fluid control. Engineers must also account for vertical elevation. A pump loses roughly 2.5 psi of capability for every foot of vertical rise to the injection point. A reliable sodium hypochlorite dosing system requires strict adherence to a three-point engineering mandate. First, verify every component in the wetted path for chemical compatibility. Second, design the suction geometry to actively prevent gas accumulation. Third, select a pump model with a flow capacity that exceeds the daily requirement to account for pressure variations. Every recurring pump failure on the facility floor is an opportunity to correct a flawed specification. Evaluate your current systems. If you are struggling with swollen seals or gas lock, the root cause is in the spec. Submit your operational parameters in the comments for an engineering review.